Welcome to the show. I'm your host, Alex Rankin. I'm thrilled today to be joined today by Kevin Wolf, CEO and how to harness near-ground and urban wind resources that traditional wind turbines miss. Spent nearly 2 decades revolutionising this space with his innovative vertical axis wind turbines that are really challenging the status quo in the space of renewable energy generation. We'll uncover not just the how of scaling an innovative product in a highly regulated industry, but also the why, the personal journey and pivotal moments that led to Wind Harvest becoming a game changer. So welcome, Kevin, and thanks again for taking the time to join us today. You could just it'd be great if you could just kick us off by talking a little bit about your journey and who's the man behind the success of Wind Harvest. And was there a particular defining moment or pivotal experience that led you to commit to this particular type of technology and how that shaped what you're doing today?
I graduated, I was a student at UC Davis getting a degree in evolution and ecology here in California. And I learned how to raft rivers. So I volunteered a lot of my time and I was on a river called the Stanislaus, and it was going to be dammed, giant dam. 20 miles of the river was going to be under the reservoir. And for somebody who loved rivers, that was a terrible price to pay for the electricity that the dam would supply. And this was way back in the early 1980s, late 1970s, when that's how old I am. That is like, there was no solar and there was nuclear, but we had 3 Mile Island here in 1979, and it was nuclear has got a problem. And we knew from President Carter's Global 2000 report that the greatest threat to humanity was increasing burning of fossil fuels and global warming. What was there we could do except dam the remaining rivers of the world? I was on this river trip with I took VIPs down for Friends of the River, and this guy founded the California League of Conservation Voters. His name was George Wagner. And he said around that campfire that night, he said, wait, there's wind energy. What do you mean wind? It pumps water out of the dikes in the Netherlands and it crushes corn, and windmills. And yeah, I got a company that we're working on this. And it's we got this vertical axis wind turbine, and you can produce energy from wind and turn it into electricity. And I was, wow, there's hope. I followed them, I connected with them, and about 4 years later, they were building prototypes up near San Francisco. And they invited me over, and I got to meet the inventor, a guy named Bob Thomas, and see the turbines, meet his son, who was also Dean, who was also a brilliant person helping with these turbines. And this is it. This is how we solve the problem of getting energy without damming rivers. I followed him, and then way back in 1990, I had some money, and I invested in the company. And I followed them, and they were at the Prince of Wales property. They were going to do a big project with a company called Zon, 20 megawatts, the first big project in England, in Wales. And the darn thing sold to a company called Enron in the middle of the deal. And Enron, we believe, took the power purchase agreement, financed it, but never put any money into the project and left us hanging there. The company almost went bankrupt. In the late 1990s, they were restarting, and I said, oh gosh, I've got shares in this company. I should help them. I'm a professional at meeting facilitation, process, strategic planning, getting people to reach consensus on decision-making. That was my career. I've traded my time for shares in the company and started volunteering and working for him in 2000. And at that time, we figured out, Bob Thomas had this idea that if you put 3 of these H-type turbines about a meter apart, that they would cause the wind to funnel in between the gaps and increase the energy output of each neighboring turbine. And vertical axis turbines had this problem. When the blade came back into the wind, it created drag. The traditional horizontal axis turbines, well, their blades kind of what they're called yaw. They turn into the wind,
Yep.
And they don't have nearly the drag that vertical axis turbines. So everybody thought that vertical axis turbines were a dead thing. They would never reach the efficiencies of horizontal axis turbines until Bob, with these 3 turbines, I got to actually help build them, install them down there, that they proved that, no, you can solve the drag problem if you put them really close together.
Yeah.
And so That was a big breakthrough for the company, but this old company had a lot of problems with finances and how its share structure was done. So they talked me into joining them as founders of Wind Harvest International. And so that was founded in 2006. And I'm working for them full time, and I've done every imaginable job in the company except the actual math of the engineering. But I facilitated the engineering team. I've got most of the projects. I've been involved in all the patents processes and grants and scientific writing and all the other things that we've done over the years as we've moved this technology through the technology readiness level process to now we're at the very end of the commercialization process with a all steel and all aluminum turbine that looks like it'll be the first one that can withstand this very turbulent wind near the ground. So the key thing that Bob and George have figured out is that there's these wind farms like in California or Australia. South Australia has fantastic wind farms with excellent winds near the ground, but it's too dang turbulent. The wind just goes all in all kinds of directions and gusts around, and the horizontal blade turbines, they need laminar flow. So they're placed high above the ground and far apart from each other, so they don't get turbulence from each other. But that leaves this space below, and not all wind farms, but wind farms where there are mountain passes or ridge lines or hills or ocean bluffs that cause the wind to speed up near the ground. And that is the market. That is the niche that we've been pursuing. How do you make a turbine strong enough, tough enough, that can last 15 million revolutions a year for decades and decades in that kind of environment? Took a lot of innovation, and I can talk to you about that, but that's the journey, how I got here.
Fantastic. Well, you've been very committed for a long time there.
So big. What can you do in your life that's big? You can bring in a technology that
Right.
is clearly useful. There's a
Yeah.
huge resource just waiting for somebody to come up with a technology, and all you got to do is keep at it and don't give up, and you'll succeed.
It's a great lesson. I'm really interested, as I've mentioned before, when I was a previous regulator in a whole lot of wind farms in Australia. And I'm sure you're well aware of all of the
Challenges?
challenges around both scientific, technical, the people that are concerned about the noise, the visual intrusion, the level of bird strike, particularly in sensitive coastal areas. So is the concept with your turbines that it sits within that type of wind farm footprint and generates wind at the base of those types of areas? Or are you thinking about potentially placing your turbines into other sites around urban areas?
Our turbines, we don't expect our turbines to be any more than at the most 30 meters tall because it's a lot of weight, a lot of steel up there, and if you put it on a taller and taller tower, you can't get the rotor to be bigger and bigger. It's not like the horizontal axis turbines where the blades get longer and longer. You got a lot of steel and aluminum in a three-dimensional rotating vertical axis turbine. It's got two arms to each blade. The blades have to be not composite. Composite can't handle the stresses near the ground. So
Right.
it's aluminum blades. So we're not going to compete with the tall turbines. What we're trying to do is go into that turbulent wind resource near the ground that the tall turbines cannot, the traditional horizontal axis turbines cannot use. And that means that we're going to be short. We're going to be as short as 20 meters
Right.
above to the top of our turbines. That's about tree height. So you will not be able to see them. Or if you put them in wind farms, those other ones are 100 to 150 meters tall.
Yeah.
So they've all changed the landscape. So that makes us an opportunity to go into places where these giant turbines can't get up the roads. They got people who do not like the damage it does to their views.
Hmm.
And the other interesting thing is that because vertical axis turbines are three-dimensional and propeller type turbines are two-dimensional, right? The blades go in and come up at an animal or down at an animal. Say three-dimensional turbine, the blades come at the animal in the horizontal plane. So animals evolved to see things coming at them, but they did not think that they were going to come down at them or up at them.
Yeah.
So they did not in that direction. Those tall turbines, those blade tips are traveling at 150 plus miles an hour. So it is enormously difficult to see them and avoid them, whereas our turbines are rotating at 40 to 80 miles an hour, and they are coming at them. So birds avoid cars a lot. They see the cars and they can go around them because they see things coming at them. The ornithologists say that birds will avoid vertical axis turbines much more readily than horizontal axis turbines. And the data out of California, the only place there were vertical axis turbines and horizontal axis turbines, the old Darius-style egg beater turbines called flow wind, they put in about 500 in California. And over in the Altamont Pass near San Jose in the San Francisco Bay Area, both sets of turbines were killing birds, a lot of birds. They did a study on it, and the verticals were half as harmful as the horizontal axis turbines. And those are two-bladed. Ours are three-bladed. We're more solid looking. All the evidence says we will be much safer for birds. But we're still going to do a lot of science. That's my background, evolution and ecology. I'm a strong environmentalist. We're going to find a way not to harm birds. And the way we're looking to do that is with motion detection camera technology that can see birds from hundreds of meters away and identify the bird by its flight pattern change in pixels in the algorithm of the computer that's associated with it. And you go, that's a flock of geese, that's an eagle, that's an owl, because you can do it 24/7. And if these birds are known to not see and avoid a vertical axis turbine, the technology sends a deterrence, light or sound. If that doesn't work, then the technology causes the turbines to slow down until the birds pass. And then the turbines start up again. So that's our plan of how we are not going to harm birds and how we're going to go into markets that are not directly competing with the horizontal. Now, one more thing is I don't want to forget it. Out of Caltech, a guy named Dr. John DeBerry once called me many years ago and asked about the paper we had written on the coupled vortex effect. When these turbines are placed very close together, they shed little whirlpools of wind. And DeBerry had observed, he's a bioengineer out of Caltech, he had observed that fish swim, and when they swim in schools, they create little vortices behind them that are synergistic with each other. He hypothesized that if you put vertical axis turbines under horizontal axis turbines, you could create an increase of energy output by both sets. So he started doing experiments on that with lots and lots of vertical axis turbines, and the data shows pretty conclusively that, yeah, if we put vertical axis turbines under tall turbines in the right places, it'll draw faster moving wind from higher altitude towards the ground. And because the energy in the wind is the cube of the wind speed, even a small increase in wind speed through the tall turbines' rotors is going to significantly increase their energy output. So the studies say that VOTs under horizontals will increase the horizontal output by about 10%. So now we get double use of the land. We get to reuse the zoning, the land, the roads, even the transmission system. If you put an AI data center on the land, then you don't need a new transmission system. And add these vertical axis turbines into land that's already ready for wind energy. So that's the play. And we think it's a huge international play that will really help the world significantly increase its energy output very quickly. Because that's the hardest part, as you know. Get the permits, get the transmission lines, get the power purchase agreements together, get all that together. That's a difficult process for a new project. But on an existing wind farm, much easier.
That's a fantastic option to be able to start off with, amplifying the sites that are already there and getting more from those, extracting more energy from those sites before you start tackling new ones in terms of your progression. What's your next steps and strategically the sort of potential interest and take-up of this type of technology?
I was telling you about those flow wind turbines that were in the Altamont Pass, the ones that look like egg beaters. They broke. In about 5 years, they all started to break, where the arm and the blade connected. So these things rotating 15 million times a year with all that force. Pretty big blade. Ours is 13 meters long and creates a lot of force on it as it rotates around. And that thing wears out. That arm blade connection wears out. And no one's ever been able to figure out how to do that. Pretty much it's been given up. that vertical axis turbines can survive. They can
Right.
solve this problem. But we came up with this little innovation called a hinge. If you put a hinge between the arm and the blade and you have a very strong pin, which are easy to get, now you've solved that problem. And if
So
you use this aluminum blade that's got these walls, I-beam walls inside that are all extruded, you can get a turbine to last 70 plus years. You got to replace the power converter. You got to take the bearings out of the drive shaft and replace them. You probably have to rewind the permanent magnet generator, but the magnets are permanent. You do a refurbishing, and then the turbine lasts another 20 years, and then you do it again, and then you do it again, and somewhere out around year 70, the turbines start to wear out down.
yeah.
But that is an enormous asset to give the next generation. You take a little bit of the steel, you turn it into a machine that produces energy, and you gift it off for multi-generations out into the future.
And presumably there are those sorts of issues with horizontal turbines as well.
You
Blades
have all of
breaking.
these problems. But back to the reason why I was telling you this story is if vertical axis turbines are a failure, and then they look at renewable energy technologies, other wind turbine companies like Ogen, a shrouded turbine, $100 million was invested in that company, or Makani Kites, Google and others put probably $150, $200 million into a new kite wind technology. Then Southwest Wind, they ate up probably $100 million before they went bankrupt. These new technologies in the space have given a bad reputation for almost any hardware-based renewable technology. So the space, the venture capital companies, the corporations, all the ones who usually would invest want to see the technology through certification. They want to see somebody else validate that it works. And then even the ones who will accept that are slim. The most of them want to see you in revenue, and they want to see you achieve what's called technology readiness level 9, the last step, which is like, okay, show me that you've got a year plus of data that your turbines operate very well for over a year, and give me 100 of those data from 100 turbines or 50 turbines. And this is the problem of how do you get through this last stage when no one will invest in you until you're proven.
So you're finding that even current operators of some of the large wind farms where they have the potential to generate additional resource from their sites would not be interested?
They are super interested, but I've talked to dozens of the biggest ones around the world over the years.
Yeah.
They all basically say the same story. We are in the business of developing wind farms. We want to be agnostic about the technology we buy. We don't want to be having to buy the technology that we invested in. We
Right.
really hope you're successful. We'd like to open up this wind resource. We know it's there. We know how profitable it'll be. So they're encouraging us, but they will not invest in us. And then the big companies like Vestas and GE and Siemens, they have no experience in vertical axis turbines. They have no computer modeling. They've never done a prototype. They don't have any engineers that know anything about it. In competition with the Chinese for ever larger horizontal axis turbines, that's where all their research and development bandwidth is extended. So
Yeah.
one of those companies said, when you get through technology readiness level 8, we'd like to buy you, because that's the milestone. As soon as you make that milestone, everybody's there. What do you do when you can't get the traditional large investors to come up with the last millions of dollars needed to accomplish this? You go to the public through crowdfunding. We've been raising money through crowdfunding, and that's what got us through technology readiness level 7, a full-scale prototype that we tested down in Texas in industry conditions, very gusty conditions. The wind speed will change 5 meters per second in 1 second. Wow, that is a huge change in wind speed, and it's hard for any technology to exist down there with that kind of change in forces so rapidly. But we did it. We got through. Our model's been validated. We got a peer-reviewed paper on the computer modeling. We redesigned the turbine, because once you've reached that stage and you've done 2 full-scale prototypes and you have a very solid computer modeling, now you can say, okay, what's the final commercial model? We went with bigger blades. We got some great modeling on that. We went with 2 arms instead of 3 arms. We really made this thing simpler, and we came up with 8 patents that we've been granted in the U.S. Patent Office for this new technology. It's okay, it's easy to assemble, easy to make. It is simple, but we got these patents on things like hinges, a hexagonal mast. No one's ever thought to make a mast that's hexagonal. They've all used pipe. Pipe's difficult to work with, but flat-sided hexagonal mast, you can drill holes, you can bolt things on. Bolting is the way to go. You don't want to weld. Welds are bad for dynamic things that rotate 15 million times a year. Solve those problems, and now we're here at the end, and we're raising money through a Start Engine, a crowdfunding platform here in the United States, and that money will get us through Technology Readiness Level 8 certification and get projects lined up that'll buy our turbines so that we can get through Technology Readiness Level 9. And then the world's our oyster.
What's your estimate of the time frame for that?
If we keep raising money like we are on a timeline for the end of May for an installation and certification. We're going through certification or third-party evaluation of our computer modeling right now, which is the most important part. Is your model actually accurate and work? That's our process. And then we have projects down in the Caribbean where the energy prices are very high.
Yeah.
And wind speeds are good trade winds, pretty much around the clock and year round. And that market is our first market. And if we're raising money also to get those projects to the point where they have a full pro forma, permits in hand, power purchase agreement in hand, lease in hand, and now you can get project financing. Getting to that stage takes a chunk of time and money. That is what we're doing now, because people won't buy your new technology if they can't get bank loans. You got to figure out another way to get your technologies in the field by the dozens so that you can get those banks to say, oh, you've got enough data, I will lend your customer $100 million on a 10-year note so they can put in 50 megawatts in a wind farm.
We've just finished COP30 challenges the world's facing in terms of dealing with climate change. Much interest at all from governments in trying to assist and help try this alternative solution?
In Europe, they formed the European Innovation Council because they identified that this hardware problem, industrial scale hardware in the renewable climate tech, can't get traditional project loans until it's proven. In the literature, it's called the Valley of Death. Technology gets through the seed stage, they do their prototyping. Now they got to make full-scale prototypes.
Yeah.
And they got to take a couple years between each round. You got to build them, test them, and make them. Take 6 months to make these new things. Then you got to go through a year or so of testing. Then you got to do it again. And then you finally do commercial, and then you can't get project loans. And so this Valley of Death, the EIC, European Innovation Council, has a grant and investment program. And we are being considered for that. But that's pretty much it. They're all saying vertical axis turbines are a failed technology. We're not going to invest in them. We will not provide grants until somebody proves that they're not a failed technology, which is kind of like, what? Isn't that what grants are for?
So you've got a few pain points there with fundraising, getting the technology accepted amongst a diverse range of regulators and energy companies.
There's no issue about being accepted once you've been certified. As you have a standard power converter that meets the grid, that's the key thing for grid interaction. You determine, will it last for the duration of the loan? That's why we think you just look at the computer modeling and look at the data and how accurate we are. And you'll see that, this thing it will last for a very long time.
Yeah.
It's like Boeing, my example is a Boeing 747. They had modeled it, but no one had ever built a full-scale one. But they had a sense it would fly and that it would last a long time. And then they built it and they flew it and voila, it did it. Now, how can you do that? Because their modeling is very solid. They know, translate its scales. They can model that plane flight and it'll fly. Our turbines will work.
Yeah.
We're there. We just need to get the investors.
Are you using any AI tools at the moment in terms of either the modeling or presenting data or even trying to solve any of your issues?
I know our engineers use some AI, but it's not in the modeling.
Yeah.
And it's really not an engineering thing yet. And we're not really the coder people. We already did a bunch of the coding for how to do the turbine. It'll come in the future. AI has been helpful in helping figure out where wind farms are around the world.
Yeah.
That's been helpful. We've identified somewhere around 20% of the world's wind farms, almost 50% of the megawatts of capacity in the world can add vertical axis turbines. The wind speeds are above 6.5 meters per second at 20 meters ground. That's a good wind speed. Some of these things are 8 to 9 meters per second. Some of the best wind resources in the world are sitting there under the tall turbines in existing wind farms.
Potentially would be able to benefit you by sort of data and information in a way that's compelling for potential investors or
Yeah,
governments.
it's already somewhat compelling if you send it and they look at all the wind farms that we found, about 50% of them, and they go, wow, that's a lot of wind farms with really excellent wind speed near the ground. And that they look it up and they go, oh, it really is true. There's a very low wind shear, or the wind speeds are good near the ground. Where there is a high wind shear on the Great Plains of the United States, it's just the wind speeds drop significantly near the ground. You have to have these places, the California wind passes, or the places in the south coast of Australia, and then you get great wind speeds near the ground.
Have you tackled the issue at all about thinking through security, supply and of production of these things?
Oh, no, it's a great question. Bob Thomas has always designed around the idea that this should be able to be made simply and easily. It's a simple machine. And we follow that tradition. Extruded aluminum blades just are pretty simple to make. They're just mass manufactured. That blade we are making in Germany, a company called Step G, and they ship those blades in land sea containers, 40-foot long, standard sea containers, to an assembly facility near the installation site. For example, we went to Australia, pretty much every piece of that equipment, the turbine, except maybe the power converter and maybe the permanent magnet generator and the blades, could be made in Australia. And probably a dozen different fabricators could all make the different parts. So you make it locally, you ship all the components to a assembly facility that you set up temporarily near
Near the
the
site.
and you bolt them to the blades and you bolt them to the arms. And once everything's been bolted together in the assembly facility, then you ship it on a flatbed truck a few miles to the installation site. And then they go up. We think that in the future we'll see a day and a turbine goes up. So you have 4 hours and you get another turbine installed. So it's a pretty simple machine. That whole concept of making things, keeping it relatively small, but we can't make them big because if we make them big, tall, then they can cause interference for the horizontal axis turbines above them. Those things cannot have turbulence. So you got to keep the verticals underneath the tall turbines. So there's a limit to how tall these things can get.
Yeah.
It's an interesting little niche. It's not in some ways it's a niche, but it's a huge niche. A couple hundred gigawatts of potential just in existing wind farms. And then those wind farms are going to double over the next couple decades and should be that near ground wind resources double as well. So it's a big, giant market.
Do you see any potential for it to work in a more of an urban space or peri-urban areas?
I love this question because most people don't think about how human cities and towns were pioneered, right? And then they go in the valley behind the windy hill and they would set up their town where it isn't windy. So people like to live in wind. But if you go to that hill on a couple miles away from the town, on top of that hill at ridgeline, it's probably windy up there, but it's not in the actual urban area. So we are super happy not to be competing for rooftop turbines. The 1 to 10 kilowatt machines that are supposed to go into residential urban areas, that market is really a lot of competition, at least 20 different companies competing for that space. We're out in the windiest parts of the world. We're at industrial scale. We're megawatt scale projects. We're not going to be selling into small residential urban areas. Now, there is a place, Cheyenne, Wyoming, where there is the Lowe's Discount Center, the Walmart Distribution Center, the Microsoft Data Center, where the winds there are close to 7 meters per second at 20 meters. the ground. And we did some analysis. They can put 5 to 10 megawatts of our turbines in and around their parking lots, where they can't put a tall turbine in because you need a setback easement
Yeah.
of one height of that turbine. Now you got to get somewhere 100, 150 meters away from the property line, all directions. And that is tough to do. But if the
Yeah.
turbine's only 25 meters, you've got lots of places now to add our turbines.
Kevin, if you were to try and wave a magic wand and solve one particular problem that you're facing that would really rocket fuel launch the trajectory of what you're trying to do, what would it be?
I would find a way to complete this $5 million raise with crowdfunding in the next month, get people like, wow, this is going to happen.
Yeah.
And then get out there, and we have everything else lined up. It's just the challenge of figuring out how to overcome the stigma of renewable energy hardware, that it's just such a littered landscape of products that didn't make it. But there is a list of fantastic companies. First Solar, these companies took 10, 15, 20 years, hundreds of millions of dollars to go through this process of prototyping and testing and prototyping and testing again and again. And then finally you're able to commercialize your product. But these are big companies now,
Yeah.
very successful. But they took a decade or two and $100+ million. Now we've only spent about $18 million to get us where we are. We are a very light invested company, and we don't need to buy manufacturing facilities. We're going to be asset light going forward.
Hmm.
But it's still, how do we get to the right investors to say, hey, this is a good thing. You should jump at this chance.
Yeah. So when you start to become commercial, will you be actually involved in the production and installation side of things?
We'll be setting up the assembly facilities for the most part, especially in the early years, and that'll be our quality control check. We'll be working with the suppliers. If they're in Australia, it'll be Australian suppliers to provide the component parts. We probably will not be in the project development business we are now.
Yeah.
Because we will have so many people wanting to buy our turbines or license our technology or license our patents, that'll keep us plenty busy. We're well set, and we're getting closer every day. I haven't been doing this for as long as I have to give up. I know that, yep, you just keep plugging away, making progress where you can, getting the money where you can, just keep making progress, and eventually you'll succeed. And we're almost there.
Thank you very much for taking the time today, Kevin, to share your insights, especially on Thanksgiving. I know that's a big thing to take a few hours out of your day, but fascinating to hear about what you're trying to achieve and the potential of what you're working on.
Yeah.
Thankful for you being willing to take the time to share your insights and experience with us. I'll definitely include some links to your site and any resources that people might find useful on the show notes for this podcast. And I'd like to wish you a happy Thanksgiving for the rest of the day with you and your loved ones, and hope you have a fantastic day.
Great. And my turkey's in the oven, so I'm happy. And I'm glad to have met you. It was a great conversation. Thank you.
Thank you very much. Appreciate it. Okay, bye.